Our goal is to make these quadrotors autonomous.
Tonight, fully autonomous robots work and fly together with absolutely no human help.
The basic idea is to rip through the explosive with a blade of water.
This life-saving device uses nothing but water to disarm roadside bombs in Afghanistan.
On the Alan Nursall Experience, we're answering viewer mail about the cleaning power of oxygen.
What if the car was grown from nature? And what if the car, at the end of its life cycle, would get composted?
Mercedes-Benz reveals the far-out and homegrown future of car design, planting the seeds here on Daily Planet.
Welcome to Daily Planet. I'm Jay Ingram.
And I'm Zaya Tong, and as you just saw, it looks like we have a very interesting show for you today. Complete with the world's largest yellow diamond and the most high-tech surfboard ever designed.
And which would you take?
Surfboard.
Of course. A little later, we're even going to show you what the world's first robot marathon looks like. But first, flying machines that can think.
Engineers are working on designing useful robots that can fly aerobatically. They can even build structures and explore buildings.
And they can do these things because these are aerial bots that can think for themselves.
That's right, and it's all happening at a lab at the University of Philadelphia. Check this out.
Okay, ready to start it?
At the University of Pennsylvania,
Now we're going to put the quadrotors in the air.
it's time to fly quad rotors. That hanging mesh protects the students from the blades.
And so once the quadrotors are in the air, we can now start the experiment.
The robot's mission: build a 3-level structure with no human help.
We work in a robotics laboratory, and our goal is to make these quadrotors autonomous and to do interesting things that would benefit society.
Vijay Kumar's students are checking out new computer code that allows the quadrotors to pick up the right part and place it in exactly the right spot. The quadrotors know what the structure is supposed to look like.
We're essentially saying, well, what if you had three-dimensional aerial robots that could basically take these parts and lower it from the top? The whole concept is new, and it has never been done by robots in an automated fashion like this before.
The robots work cooperatively. One waits at a safe distance until the other one has safely installed its part. Only then does it move in. The parts snap together with the help of magnets.
The quadrotors are very agile micro aerial vehicles. They're agile because you have 4 rotors that can be controlled independently to perform all kinds of aggressive maneuvers.
In their quest to make robots autonomous, the researchers have programmed them to make a plan and execute it, to see a goal and go for it. With the help of a little Velcro, a quadrotor can perch even at an extreme angle. In another part of the lab, a different experiment. A big quadrotor must navigate hallways that are strange to it.
In this experiment, what we're going to see is the quadrotor flying around the environment, looking at the environment around it using a laser and a camera, as well as an inertial measurement unit on board, and taking all that information and using that to build a map of its environment, as well as localize itself in that environment. So as it's flying, it's going to be building that map, but that map is based on how it moves.
PhD candidate Frank Shen is not guiding this robot. The only thing he's doing is giving it a destination, but it's not perfect. When the quadrotor nears objects or walls, the rotors can create a vacuum right next to it, and it'll suck itself into objects. Pumps in a water bottle too, then it corrects itself and steers back on course.
So let's go back down to the robot before it starts getting away from us. So the robot itself is learning about the environment based on this sensor input, but it's changing that map in time if new obstacles are introduced or if obstacles disappear. So for example, if I wanted to, I could go and I could stand in the way of the robot. and it would fly around me. And the reason why is because really the lasers on board and the camera on board are detecting me, and they're putting me into the map. And they plan to make sure that they don't hit me.
The only thing that slows down a quadrotor is low batteries.
So one of the major limiting factors of a model like this is that it consumes an enormous amount of power, and that's an engineering challenge.
These small robots don't have onboard sensors. They use motion capture technology. Cameras look for infrared light that reflects off marker balls located on the robot and other surfaces. The system gives the robot positions precise to within a millimeter. But Quadrotor Bravo is having a problem.
Now, if the part has not been placed successfully, then it won't snap into place, obviously. So the quadrotor simply does a yawing moment, so it tries to twist the part. Now, if the part hasn't been placed successfully, the part will be able to twist freely, and the quadrotor can determine that it's able to twist the part, and it tries to fly back up and then repeat.
Bravo will keep trying until it gets it right, or until it runs out of power.
We're also interested in having these robots go into environments where humans cannot go. So imagine a hostage type setting where you have police workers who are rescue workers or the police who are interested in finding out, where the hostages are, where the bad guys are.
After 8 tries, Quadrotor Bravo gets it right. It seems persistence is something robots and their creators are good at.